Hello. So I'm going to talk real quick about your lab because we're also going to talk about how the labs went yesterday or last week. So here you can see your lab is up. I gave you some comments on this sort of stuff, but you've got a great way. You've got your data table. In other words, you've got it separated into before and after heating. Keep that kind of style. You've got boxes. That's good. But then each of these lines that you have, like you have 3 lines there on each of them, those should be their own box. So like there's a mass. So you have before heating, after heating. You could put mass as the first column, put them in there. And then you talk about observations. That could be the next column, observations, and then take that second line out of both of them. And then the third line could be the weight after, mass after would be the best, because I can see you have that right there. So that's would be your 3 columns. Like you have 3 kind of data points. You only want one thing per column. You want to open up my lab and take a look at mine. Here's an example of my data table. See how I did before and after, just like you. But then I've got the different substances and their masses, and then I have observations. So yours was just kind of flipped on its side, which is totally fine. But whichever way you do it is completely fine. But you have the basics of all the stuff I do. I just arranged it differently. So when you're making a data table, make sure to take one idea per box. So either you put in numbers or you put in words, but you can't put words and numbers in a box. Observation box is always a good idea. I put in the time heated. You wouldn't necessarily have to do that. We'll kind of talk about that as we get into the procedure kind of writing. But the other thing you're missing is like a beefy title. So mass of compounds before and after heating would be a good title. It can't just be like data table or before reaction or masses. It has to be like a sentence of a title. Okay. You did great on your stoic part. And then taking a look at the errors. So I got more Na2CO3 than I predicted. This might be due to the lack of stirring, which doesn't allow the heat to reach as much NaHCO3 as possible, which may have caused that loss of reaction. That's really quite awesome. So you're doing a great job on the error part. I want to talk to you a little bit more about errors. Oh, I guess I'm putting more comments in. But the idea for an error is it needs to be the predominant error, the most likely thing that happened. For yours, that's the most likely thing that happened. You got too high, so it didn't react all the way. Or maybe some of the water was trapped in. I'll show you my lab. And then you need to really explain it, like talk about, well, why would that lead to not having as much or having too many? And you did that there. You said, I didn't have, I had too high of a number because not all of the NaHCO3 reacted. That was really good. Some people's labs, if I can go and show you, where do I have that? Right here. Come on. Okay, so some folks' labs, like this one here, you might want to pause it to really read it, but my prediction was greater than the amount. This could be because of sig figs, but that top answer didn't really go to explain it. This bottom answer down here really explained it. They're both the same error about sig figs, but the bottom one really explains it. And these are people from your class. So looking at, definitely give that a pause. Looking at here, like when you think about errors, a good error, we'll talk about the predominant error, so that's the main error in your lab, and then we'll talk about how the magnitude calculated was different. So the other that because of this error, I got too high of a number. Because of this error, I got too low of a number, and you did that. Do that part too. This one down here, they got too small of a number, so they think some of the Na2CO3 disappeared. This is an okay error, but got to go a little bit deeper into there, and then I was going to talk about yours too. Okay. Looking back at the lab report then. Got too many tabs open here, don't I? So you have access to this. So this is what we're trying to get to at the end of the year. It's not super long. You can see it's just one page. We got purpose, procedure. We'll get to that. Data table we're working on right now. We can do calculations. And then error. So you want to go and look at my error. I said I wanted to make 1.3 grams, and I actually did make 1.3 grams. So it suggests like, oh, there's no error at all. But I go into talking about how 2 errors canceled each other out, which could be possible or not. As you guys get better at errors, I think you'll be able to see this type of thing. Would I expect you to do this kind of answer on this lab? No, probably not. But my answer was the idea like, I stirred it, so some of it was lost. That was an error I saw a lot of people do. And then I also want to talk about how yours, like you said, not all of the NaHCO3 got enough heat. Well, I was suggesting that some of it got trapped underneath this like cap, and then that didn't allow all the water to escape. Now the point, once again, read through the error carefully, but the point you want to do here is, since I talked about a viscouple cap, like observations, I had to make sure I have observations in my table. Otherwise, you'd be like, well, where'd they come up with this stuff? So you need observations in your table if you talk about it in your lab. If you don't talk in your lab, you don't have to have observations in there. You can, but you don't have to. So, and then the last would be conclusion, and we have actually already talked about conclusion. We are writing CERs for that. So, if I go back to... So this is the conclusion that's in the lab. You can see the blue is our claim, our evidence is this yellow, and our reasoning is the green. That is what makes a good conclusion, is the CER, which we have been working on. Okay, those are the things I want to talk about for the lab.